Dear students, welcome to the problem solving basics on discrete random variable. In this session, we are going to learn how to solve problems on discrete random variable. What are all the techniques we are going to use to solve this problem? A discrete random variable always take countable values which may be finite or countably infinite. We see the basic definitions, what is meant by countable, uncountable, countably infinite, etc. in the first video. Now, in problem solving point of view, we cannot take countably infinite. So we are going to take only finite values. For example, let us consider a finite discrete random variable. We take a dice. When we throw a dice, we have a chance of getting any one of the values from 1 to 6. Now, I can represent this in terms of a table. The outcomes are 1, 2, 3, 4, 5 and 6 and their corresponding probabilities are 1 by 6 everywhere. If I write this in terms of a table, then it is known as probability distribution. Here, capital X is finite. It takes the values 1, 2, 3 up to 6. This is a finite discrete probability distribution. Now let us see the notations which we are going to use in our problem solving. Capital X means always a random variable. When I say small x, it takes the values. For example, you say what is the probability of getting 1 when you throw a dice. So this is random variable and the small x is the values. So now I can write the notation capital X equal to X, or that is equivalent to small p of small x. I prefer this notation throughout my problem solving. So P of capital X equal to X is nothing but probability that X equal to the values small x. That is equivalent to small p of small x. Both have same meaning. These are all some examples. So probability of getting X equal to 3 is equal to small p of 3. Just now we see probability distribution. If you write the X and corresponding their probabilities in a table, it is known as probability distribution table. Here, let's take countable values, that is x1, x2, x3, etc. Suppose you take integers. What is the next value of 2? You say it is 3. What is the predecessor? It is going to be 1. Therefore, capital X always take only countable values and their corresponding probabilities. And very important, their probability should be lies between 0 to 1 and total probability is always 1. That is, summing all the probabilities we get 1. These two things you have to keep in mind for problem solving purposes. Now let us go into the clear picture of how questions can be asked in terms of discrete random variable. The essential question, they will tell you to find the constant. You will be given some constant like A, K, C, B, etc. We have to find that first. You see the question, the discrete random variable having the probability function X and then their probabilities are given. We want to find A first. So either A or C or K. These things we have to find. How to find this? It is very simple. We know that sum of the probability is always 1. So if you add all this probability, that is going to be 1. And then from this easily you can find the A value. So here the A is 1 by 81. What are all the different kinds of questions they are going to ask with this table? They can ask like probability of X less than 2, less than or equal to 2, greater than 7, greater than or equal to 7, etc. Now let us see how to tackle this. The first task, to find probability of X less than 2. Probability of X less than 2 means from the question you can easily weave it. We have only two values, 0 and 1. So I can write this as probability of X equal to 0 plus probability of X equal to 1. Now their corresponding probabilities are A and 3A. So my answer is 4A. Better you substitute the A value at the end of the problem if this is simple. Don't substitute the A value in the beginning. It makes your problem complicated or you may do some errors. So my answer is 4 by A. We know A is 1 by 81 At the end you write simply 4 by 81. If they ask you to find probability of x less than or equal to 2, then you have to include 2 also. So it's going to be probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. So we have 3 values. We have to add this and then finally substitute the a value. Next, probability of x greater than 7. So it's going to be very simple. If it is greater than 7 means we have only one value, that is probability of x equal to 8. So 17a, we can substitute and get 17 by 81. Greater than or equal to 7 means we have to include both 7 and 8. So the answer is 32 by 81. Now we have to look carefully. Probability of x greater than 2. If it is greater than 2, we have to take 3, 4, 5, 6, 7, 8, etc. And then we have to add their corresponding probabilities. This is one way. Now the answer is 72 by 81 since a value is 1 by 81. What is the other way? Using complement rule. You know, if I ask my success is 80%, immediately you tell my failure is 20%. Reason? The total thing is 100%. The same thing, when I say probability of x greater than 2, it is equivalent to 1 minus probability of x less than or equal to 2. In the similar way, if I tell probability of x greater than or equal to 2, then it is equal to 1 minus probability of x less than 2. Because the total probability is 1. It is easy to see probability of x greater than 2 plus probability of x less than or equal to 2 is always 1, because when I take probability of x greater than 2, I can cover 3 to 8. When I take probability of x less than or equal to 2, I will cover the 0, 1, 2. So the total probability is always going to be 1. So from this, I can write probability of x greater than 2 is 1 minus probability of x less than or equal to 2. Now 1 minus probability of x less than or equal to 2 means it covers this 3 values. So I can add probability of x equal to 0, 1 and 2, and then I subtract with 1. So we have 1 minus 9 by 81. So we can write this as 72 by 81. Either you go the previous way, directly adding the probabilities from 3 to 8, or you can use complement. Whichever it is easy for you, you can go in that way. So in the similar way, probability of x greater than or equal to 2 means we have to cover from 2 to 8, or if you are smart, you can go for the complement method. You can simply write 1 minus probability of x less than 2. It is simply probability of x equal to 0 and 1. And we can subtract from 1. So 1 minus 4a. So it is going to be 1 minus 4 by 81. You simplify and you can write. Next question. They can ask probability of x lying between some values like 2 to 4. And then here they can ask different kind of inequalities. Sometimes less than or equal to both sides or left or in the right, etc. Let us see one by one. So now we are going to explore these 4 cases. Probability of x lying between 1 to 3. Then you should not include 1 and 3. Then only option is probability of x equal to 2. That is 5a. That is 5a. Next, probability of x lies between 1 to 3 but including 3. So in this case, we have to take 2 and 3. So this is very easy, students. You can easily get it. In the similar way, if I say 1 less than or equal to x less than 3, then we can take the values 3a plus 5a, that is 8a. And the next one, 1 less than or equal to x less than or equal to 3, then we have to include 1, 2 and 3, and we have to write their probabilities. Final answer is 15 by 81. The next type of question is modulus questions. They will ask mod x less than or equal to 1, less than 1, greater than or equal to 1, greater than 1, etc. How to deal mod x problems? For that, first of all, we have to understand the meaning of mod x. Mod x is the distance of x from 0 in the real line. This is the definition of mod x. Whenever the values is greater than or equal to 0, mod x is simply x. Whenever the value x less than 0, mod x is going to be minus x. Then only if you substitute any value, minus into minus plus, always you get the positive value. Now, in the problem, they are asking like mod x less than a, mod x less than 2, mod x less than 3, etc. How to deal this? Before going to the problem, we have to understand what is the meaning of mod x less than a. Mod x less than a means x lies between minus a to plus a, and we should not include this minus a and plus a. We can see the graphical interpretations on the x-axis. Mod x less than a means the distance of x from 0, which is less than a. So here minus a and a should not be included. If they ask mod x less than or equal to a, the only difference is we have to include a and minus a. And next, if they ask mod x greater than a, we should be very careful, because mod x greater than a means x should be greater than a, it goes up to infinity, and x should be less than minus a, it goes up to minus infinity. We can see the graphical interpretations in the screen. Similarly, we can see mod x greater than or equal to a means we have to include a and minus a alone. But in the problem solving point of view, if they ask probability of mod x less than or equal to 1, I can solve easily. But if they ask probability of mod x greater than or equal to 1, it is tough to solve. So better I can use the complement formula, 1 minus probability of mod x less than 1. And it is easy to find mod x less than 1, that is x lies between minus 1 to 1. Find the probability of mod x less than or equal to 1. This is equal to x lies between minus 1 to 1. Now from the table we know the probability of x equal to 0 and probability of x equal to 1. But we don't know what is the probability of x equal to minus 1. It is not provided in the table. If something is not provided in the table, it is out of box. We can simply take this as 0. So probability of x equal to minus 1 is going to be 0. Then we add the remaining thing and we proceed. If they ask probability of mod x greater than or equal to 1, as I said, we have to go by 1 minus probability of mod x less than 1. So it is nothing but 1 minus probability of x lies between minus 1 to 1. So minus 1 to 1, we have only one value, that is 0. So 1 minus probability of x equal to 0. Simply we can write this as 1 minus a. This is one way. Or the other way, we have to take what are all the values which is greater than or equal to plus 1 and less than or equal to minus 1. Since in the problem there is no negative values, this case is nothing, it is simply 0. Now we have to add all the probabilities from 1 to 8 and then we have to write the answer. So choice is yours. Either you can use complement or you can add directly. Next, they can ask you questions on conditional probability. What is conditional probability? Probability of A provided B is already happened. So they can ask either B bar A or A bar B. So probability of A bar B is nothing but event A occurs provided event B is already occurred. So probability of A bar B is probability of A intersection B divided by probability of B. If you want to express probability of B bar A, the only difference is denominator. If you have A bar B, you get P of B in the denominator. If you have B bar A, you get P of A in the denominator, and numerator is going to be common A intersection B, and it is very important the denominator should be greater than 0. If it is equal to 0, it is meaningless because probability always lies between 0 to 1. It cannot be infinity. So they can ask you questions like this. Probability of x greater than 1 provided probability of x less than 3 already happened. So these kind of questions we are going to see how to tackle at the time of problem solving. The next question they will ask on CDF. Find the cumulative distribution function, or simply distribution function, or simply they will tell find the distribution. All are same. So now how to find cumulative distribution function? The formula for cumulative distribution function is capital F of x. This is nothing but probability of x less than or equal to x. So if I am asking to find f of 0, you have to add up to 0. Here the first value is 0. So simply we write x equal to 0. So it is a. If they ask you to find f of 2, that means probability of x less than or equal to 2. So we have to add up to 2. So it is nothing but probability of x equal to 0 plus probability of x equal to 1 and probability of x equal to 2. So a plus 3a plus 5a, it is going to be 9a. In the similar way, one can easily calculate what is f of 5, f of 7, etc. Next, we have to find mean, variance, and they will ask like find e of x minus 3, find v of 3x minus 4, etc. The formula for expectation e of x is summation x into probability of x. In the table, you have to multiply the x with their corresponding probabilities. In exam point of view, find e of x or find expectation of x or find mean or find mu. Everything is going to be the same. Next, they will tell you to find variance. Variance of x is e of x square minus e of x whole square. To find the variance, we need both this data. We know e of x is x into probability of x, and e of x square is very simple, summation x square into probability of x. And we can easily found this from the given table. And sometimes they will ask standard deviation of x. It is positive square root of variance of x. Now let us see some properties of mean and variance. Expectation of a constant c is always c. Variance of a constant is 0. Next, e of ax, where a is constant, x is a random variable, then we have to express this as a into e of x. But in the case of variance, a into x is going to be a square into variance of x. Next, e of ax plus b, where a and b are constants, it satisfies linear property. So I can write this as e of ax plus e of b. Since a and b are constant, expectation of b is b, and using the previous rule, I can write this as a into e of x. But in the case of variance, variance of ax plus b is variance of ax plus variance of b. We know that variance of constant is 0. And using this property, I can write this as a square into variance of x. In the similar way, if you have minus instead of plus, you are going to get just minus. You can see this. So e of x formula once again, summation x into probability of x. And variance of x formula is e of x square minus e of x whole square. For this we need e of x square. It's nothing but summation x square into probability of x. So standard deviation of ax plus b is simply modulus of a into standard deviation of x, because standard deviation is positive square root of variance. And sometimes they will ask you some inequalities, find the maximum value or find the minimum value of some c which is given in the question. Using the table, we have to find. For this, it is very important to find the CDF, because the CDF formula is capital F of small x is nothing but probability of x less than or equal to x. So once you find CDF, from this we can easily find this. These are all the different kinds of questions can be asked in the problem solving. Hope now you are clear how to tackle each kind of questions. In the next session, we are going to solve problems on discrete random variable.